All right, well, here's a lecture on getting started with R. So your first task is just to click on this link right here with the CRAN project, and that will take you to downloading R. You'll need to select your system, whichever that is. Then I strongly encourage you also to download RStudio, so it's free. And be sure to select the free version. So um, just click on download. Then you're going to choose your version. So get the RStudio desktop open source license, and that'll be free. Okay. So once you download those two things, um, here's just a few things that you can do in R. Okay. So here's my RStudio, what it looks like. And one of the things you can do is you can install a package. This package happens to contain data sets, but other packages will contain mathematical operations or functions in which it will do mathematics to your object for you, so you don't have to calculate it by hand. Okay. So it'll ask you, do you want to update and do you want to download a package? So you will click yes, but I'm going to click no because I already have this package installed. So here, since I already have the package, and once you install the package, you can download it by just doing this library sleuth 3. So this is the script area. So it's decided to install it anyway. And here is where it ran. So down here, this is your output. And I can click between writing a script, which can be executed at any time later, or doing it dynamic. So I can enter a calculation in here. 5 plus 11, hit enter. I'll get 16. Okay. So I said this package contains data sets. One of them is this one, example 1223. This head command displays just a little snippet of the data. So it contains the first 6 entries of your data set. And it gives me every single column that I can access. So I can access subject, magazine, newspaper, library, family income, the race, the gender, the education of the individual. And if I want to read a little bit more about what this data set is, or if at any point I need help, I can use the question mark. So another thing is that these hashtags, this is a comment to tell you that question mark gives you help or documentation. Okay. So I need to ask for help on something. I'll ask for help on this data set, 1223. And on the right is going to give me these IQ scores and income. It tells me about this data set. So it tells me it's from the library sleuth 3. It's a subset of 2,584 individuals from the National Longitude Study of Youth. Okay, and it tells me a little bit about each of these examples. Okay, so each column AFQT is the percentile score on the intelligence test in 1981. It tells me all about these things. Okay. So one thing is that when I look at my data, there's a column that's called science. There's science, and if I want to know what science is, I can look it up here. Score on the general science test in 1981. And if I want the total score, I can type, what this does is it sums every single score in the data set. So that would be the sum of the science, the sum of every one single score. If I wanted the average score, I can do this. I can do mean here. and the mean score, average score, is 16.3. I can also figure out what the sum of the scores are for just women on the category or column of science in this data set. This is a subsetting command. Both of these are. The $sign says access that column called science. This which command says access only the individuals who are female. So for example, if I just execute this little bit right here, this is subsetting. And this gives me only the data for females on all columns. Okay. I should have typed head there. And in fact, it displayed a lot more output than I wanted. So I'm just going to type head of that. Okay. And it'll just show me the first 6 entries. Okay. So here are the first 6 entries, 1, 2, 3, 4, 5, 6. And the reason why it doesn't go 1 through 12 or 1 through 6 is because subject column 1 is a female, column 4 is a female, column 7 is a female. It's giving me all columns, but only the individuals I selected or subsetted on this category right here, where we have gender. Gender here is always female, and that wasn't the case when I typed the data in without this which command right here. Okay, so I'm subsetting it, and now I'm going to access just this column of this data set. I'm going to access science, and I'm going to sum all those scores. It gives me 19,571. If I wanted to figure out what the average score is, I could figure out what that is for females. I could figure out what the score would be for males. So let me put mean right there. Okay, 15.3 is the mean score for females. So these are common operations that you might deal with if you were given data. Okay, we're going to use R on the side from time to time to help us with calculations. If we do a data analysis, I want you to be able to access R. Okay. So one other thing that's going to be very important is a for loop in R, and here's our first example. So I'm going to set R equal to 1/5, and I'm going to set S to be 0 initially. What I'm going to do is that S is going to be equal to the previous value of S, and I'm going to add the first value of R. Let me do this from 0 to 10. Okay. And I'm going to keep doing this. This creates a series. So in R, I'm calculating the value of a series, and at the end of it, I'm going to print its value. I get 1.25 as its final value. What happens if I only took the first 5 terms of the series? It's still giving me 1.25, but I think it rounded. Okay. What if I did just the first 2? 1.24. Okay. Now remember, the first value of S is going to be 0. It's going to be R to the 0, which is 1. So it's adding those values. Okay. Now here's an example of a function. This function takes an input of x, then what it does is it sets y equal to twice x plus 1, and it returns that value. So if I plugged in, I don't know, like 2, is going to plug in 2 in for x, and I'm going to multiply it by 2, that'll give me 4, add 1 gives me 5, and it's going to return that value. So I first have to define it, so highlight that, and by the way, I've been using this hotkey in R, so on a Mac, which is what I'm using, it's Command Enter, and it executed that. Now, it returns this output down here. Okay. Now I can hit Control and Command Enter here, and it says the function of 2 is 5. So great, I can define a simple function. Why did I go through that? I can combine this for loop, which takes an argument of r, and how much of the partial series I want, and I can define that into a function. So here I could do r and n, and I could feed in 1/5 and, I don't know, 25. So what this does is it sets the sum to be 0. It adds the sum to the previous sum and adds from the exponent of 0 and adds all the way up to n. I'm setting n equal to 25 here, and I'm setting r equal to 1/5. So here's a function, and it returns 1.25. It's exactly the same value I got before. But one reason I can do this, I can easily change the value without rewriting the code. So for example, I could do 1/2 and I could do 20 like that, and I can get a value of 2. Okay. Notice it is rounding here. Okay. Now here's another function, and it's called the factorial. The factorial is generated by multiplying all the previous values. So what it does, it feeds in the value I want to take the factorial of. It sets the factorial equal to 1. Then I loop from 1 to n, and I multiply by all the values between 1 and n. So for example, if I do 3 factorial, that'll be 3 times 2 times 1. Some common things that you're going to have to do when you're dealing with R is to create a function, to do some subsetting with your data, but also randomness. Okay, so random variables. Okay, here's one of the most common random variables, and it's the normal distribution. I'm going to do R norm, because if I want to figure out how to use the normal distribution, I might do that. So the normal distribution appears right here, and it tells you what arguments it takes. There's a couple of different usages. I'm going to use the rnorm command. If I wanted to get a single value of an R norm, I'm going to take mean 0, variance 1, and I'm going to take a single value there. Excuse me. Looking over this documentation, the sample size I want, n, comes first. So I'll take 1, 0, 1. A single random variable of mean 0, variance 1. And it gives me a minus 0.67. If I re-execute that line, it's going to give me a new value. It's a coincidence that is almost exactly the same, but a positive. So I can keep executing that, and I'll get different values each time. And you see the values as they appear right here in the bottom. Instead of having to re-execute it, I could take 10 of them like that. I could take more. I could take something like 50. Okay. And if I want to see what they look like, something that you'll do in chapter 6 of this course is going to be to take a histogram. And it's much better to have to do that with R rather than do it by hand. It'll take you 5 times as long. So here's the histogram of the normal distribution appears on the right. Later we'll talk about the fact that it should be bell-shaped and symmetric. I'm going to fill in this to make 500 observations when I make my histogram. It'll look a lot more normal. There we go. I like that. It looks great. It looks much more symmetrical and balanced. Okay. So that's an example of reading of random variables. There's others that we'll encounter, like R binomial. Okay. I see it didn't come up. And here is the binomial distribution. We'll talk about that also in more detail. Okay. So there are other random variables. The binomial corresponds to like flipping a coin. Okay. I want to go over reading a data set. Okay, so there's one very important thing to do when you're reading in a data set. That is to set your working directory. So I'm going to save this. I've already saved it, but I'll save it again because I have new changes. I have this file called 3410, and it's in that folder. So I'm going to save it, okay? And I'm going to replace it because I have made updates anyway. And for this session, there's something called set working directory. The most easiest to use is the source file location. And I'm going to, you need to make sure that you're in that. So this is just setting your working directory. You don't actually need to type this command, you just need to use set working directory under session. Do this under the session window. Okay. Then I'm going to name the data. So first I'm going to create a data set, and I'm going to use Excel to enter data. Okay. Let's see. So here's Excel. Let's see. So I got this data set. It's going to have a last name. So last name's Chan. I'm like 60 years old. My location's in Ogden. I have $100. Great. Pretty realistic. Let's do some others. So Monty. And he's going to be age 22. He's also in Ogden. He has way more money than me, $1,500. And let's make a hippie. They're also going to be in Ogden. They're going to be 50, and they're going to have that much money. That's a lot more money. And we'll also have Alan. He's going to be age 33 in Salt Lake City, and he's going to make a boku bucks. And Jenny is going to be also in Salt Lake City, and she's going to make that much money. Okay, and so I'm just going to save this. So you could have different headers for your data. So there could be different things instead of last name, instead of age, instead of location. It could be gender, it could be political affiliation, anything you want. But this is just an example of entering data. Okay. So I'm going to save this, and I'm going to save it in the same folder that I have. So that's a different project I've been working on. So example 1 is what it's going to be named. And I'm going to save it, this is very important, I'm going to save it as a CSV because I strongly prefer CSV files. Okay. You can do Excel, but what I'm about to do in R will not work for you then. Okay. So data, I'm going to name that into the read.csv, and it's going to be example1.csv. And I should have done this at the beginning. Everything should be in quotes here. And because the first row that was entered was describing the data set, I do header equals true. Okay. I executed it, so great. It executed, it returned nothing. That's either great or horrible, as they say in computer science. Great, because it either worked or it didn't, but you don't know until you ask to see the data. So let's ask to see the data and look at the head of it. So here's going to be the head. I've got last name, I got age, I got location, and notice I did last.name instead of last space name. That's because in R and in most computer languages, spaces can be a pain to work with. So use underscores or periods, okay? And try not to use spaces unless you have to, okay? Now, if I want to pull the data and just look at it, it automatically shows me which columns I could access. I could access last name, and there we go. I've got Chan, Monty, Hippie, Alan, and Jenny. If I want to do something like access the age, I can look at age, and that comes up, and I can do that. Maybe I don't like typing the name of the data set, which is data, every single time. Notice I assigned it that name. Okay, the file name was example1.csv. I can do this thing. It's called the attach data. And now we're just going to ignore all of these things that says are mass. Don't worry about that. Now when I type age, I don't have to type that data, then the $sign. The $sign says I'm accessing a certain column. Now I can just type the column name. And now I could do something like mean of the age. And I get 40.6. Wow, we're old. And so that was your introduction to R. You have a couple of questions that you can answer just by copying and pasting the code into RStudio and executing it and selecting the answer that matches it. You'll also have this file. You can use this file at your own leisure and execute it and run it while you're taking your quiz on R. Okay, that's all there is for today. Thank you.